see if we can get started. So I think we had a bug here. Oh. I bumped up my stream. This should be clear, hopefully. Guess I need to check it out. That was not cool. Yeah, it looks a lot better for the quality. Okay. So I don't think our buffer was getting filled. Yeah, that or I was overwriting stuff because I did the wrong thing. So we know it prints. If I just run it, but if I run it with yes, I think if we put buffer here, that part works, I'm pretty sure. Yeah, so buffer has our number. I just hard coded that. So I feel like we're doing a lot here to write it on our own. So we load our top index, get the value of it. So I think we should break here at test size. Okay. So what is R14? R14 has 0 in it. R14 should have 0. Okay, so we move it and do an add. So now R13 has 3. Saves the size of the data written to the buffer. So it wrote 3 characters, so that's how many characters we need to write. So this is how many, 4 is how many we need to write. So we got 3 characters. So it should not jump. Yeah. AL gets the underscore. And then R13 is going to have our value here. So let's see. So now R13 should have a pointer. Okay, so this should be our buffer. R13 should have our buffer. Oh, so R13, yeah, it has top index. So if we get the value at that, 0, so we're at index 0. Okay. R12 should have the address of that. Okay, so there's nothing in R12. S is, I think, string. X is hex, and I can do 16, 15x, doesn't matter. So it knows that those are bytes. Okay, so add, so R13 is 0, right? We're at, that's the index. And then what's in AL? AL should have our character. 5e. So then I should move that into that location. Now if I examine that, I have a 5e at index 0. Okay. Should be adding R13, so now it's going to be 4. Or no. Oh, R13 is my top index, okay. And then I'll save that. Increment R13. Increment R13. LEA. R12. And then we do a move of R13 into R12, so top index should get saved. Here's an increment, save it. Okay, increment R14. R14 plus R15. Oh. Total written. R14. Well, I added 1 to it. So it's written 1. Okay. R14 is 1. We're going to jump back up to the top. So now R13 should have 4. Yep. Jump greater than or equal to. So it should be taken. All right, so now we are at right string. So I should move the top into RDI. Top should be 1. Yep, because I wrote 1 character to it. Okay. So that has our starting location. RSI is the start of the buffer, right? So we're getting ready to write the buffer. So R12 has our address. We take our address and add so that's our top index. Because I've already written 1 buffer. And I have 1 byte. Okay. So I add my offset. So RDI is my offset. Okay. Now I need to load the buffer address and add the index that I want. So if I examine this, sorry. So buffer should be in R13. Yep, so that has 200. If I Alright, that should be 2 yep, 200. Okay. So move this byte into R14. So R13 has buffer, so it should get hex 32. So R14 should have hex 32. Okay, so I got the byte out of the buffer compared to null. Then I'm going to move R14 into the address pointed to by R12. Let's examine $R12. Okay, so that's right. So it should move that, but I'll move R14 into R12. Yeah, I don't want to move the whole thing. I think that's where my problem is. I need to move a byte. So this is taking a byte and making it bigger. This should let me take a byte and make it smaller. See, I think I need to use like, I think I looked at this earlier. I need to move. I don't think I should do that. I should do AL. Then I don't need to say byte. I say AL, one of my 8-bit registers. Now that should be right. So now if I change that to from buffer to top line, nothing. Well, let's put a breakpoint in where I think it's broken. See, I think it's in do next. I think there's something wrong there. So top line should be in R12. Buffer is in R13. I move my byte. AL has our character. It should not be equal. We're not done. Examine $R12. And if we go back -1, we should see, yep, EC5E. So I see my character in there. So now if I step, so I got caret 2. Okay, that's right. Increment RSI, increment RDI. So the pointers should go next. Jump back up to the top. What values do RSI and RDI have? Yeah, one's at 1, one's at 2, right? Because 1 points to 1, 1 points to 2. Yep. Okay, so that seems right. So now what's in AL? 30, which I think is our 0. Okay, so this it should be done. So if I examine, so I got hat 200. Well, that's good. All right. Well, let's do step So now what are we doing? All right, so we did this. So now oh, see, that's wrong. That should be top index. Got it to work. Yeah, that's good. Okay. So it was able to, even though our spaces are little hats, right? It was able to add to that buffer. So if we called it, let's see, let's make sure we're, I'm not sure we're writing a null in there. Compare AL to 0. Actually, if we put that after, we write the character, then we will, when it's 0, then we say we're done. When it's got to that 0. There should be a 0 there. Clearly there was. We don't need to increment those, but we do need to jump to where we're done. So if we call this function twice and then print it, they got concatenated. All right, it's keeping track of where the index is for that line. Go ahead and concatenate. So right here we are using so if you eventually wanted to extract this, that's a lot of lines. But we got it working. Even though we hard coded it. I think the print justified worked. So whatever's in RDI, it will put that in the buffer and then top index will be how, so what position in that buffer we are at. So that's your offset. That's your destination buffer, and then this is our source buffer. The source buffer gets filled by this, using that number. I mean, so we could put some additional things in if we wanted to. I think we can make these parameters, and that would be okay. Okay, so if we're gonna print off our numbers like this, so we got the part where we can print off this, and it actually should work for that as well. So if I take my number, say it's 200, and so let's use so a realistic number is 128. So I got 128 in RDI. So I want to print 128, and then I want to print a 1. Those are going to be in 2 different buffers when we do it for real. Yeah, I can't do that. Because we'll do 1 and we'll do 128. Yeah, we don't need to. Calling that twice. Oh, it did work. So this print justified really needs to take a couple of additional parameters. So RSI and RDX. So the buffers that we want to write to, and then the index. So let's say, so RDI has a number to print. RSI has the buffer to print to. RDX has the offset into the buffer. So offset is going to be the index. Hopefully I didn't use our index, and that should be a pointer. So these should be moves. Okay. Okay. I don't think I use RDX anywhere else. Move. Okay. And then when it says top line, so that should be RSI. I did use RSI. Okay, so where should we move it? We should move it somewhere. So I'm using RSI there, Using R13, R12, R12, R13, R14. Where am I using RSI? I'm just using it there for my buffer. So if I use R15, R11, not using R11. So now instead of top line, use R11. Which was here. Again, this becomes a move now. Buffer in R11. Buffer in R11. I should really say destination buffer. Question is, does it run? Yeah. Oh, I need to pass in my buffers, of course. So RSI. That would help. RSI should have the address. RDX as the index. Oh. No, buffers in R11. Okay, buffers in R11. But I should probably do this right. 11, 12, 12, 11. Where else did I? Did some changing. Like this should really be able to be. remove some of my intermediate ones. So that should help. But it still shouldn't have... Clearly I did something wrong. So RSI I'm using there, which is fine. I'm wondering if it's because I've used... Oh, I saved R11 and R12. I should be able to use 13, 14, 15. But it's seg faulted. It's hard to tell when it's seg faulted. Sometimes it seg faults before it finishes the print, unless I... Oh, I'm calling this twice. Should probably do that twice. I really don't need to. Let's just do it one time. So let's break a more branch string. Okay. Well, that is not great placement. Okay. So 5e is our hat that we're writing, so that should go. So it wrote 1. So it should be R. Why does R11 have... R11 should have something in it. It has 80. That seems wrong. Let's break here then. RDI has 18. RSI has ST1234. But if we step through, RDX, that looks like a pointer. RSI, that looks like a pointer. RDI, okay, I guess it's a, yeah, okay. So RSI and RDX. RDX has the offset into the buffer. Yeah, so that should be a number. RSI has the buffer, so that's a pointer to the buffer. Is an RSI. So RSI and RDX. Those seem fine. Okay. So I wanted to break here, break right string. I think it's breaking on this. So R12. What's in R11? Did SNPrintf break R11? Oh, possibly. 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 The R11 shouldn't. Oh, and I'm also I know that's not a call. 12 on 11. Oh, yeah. If I'm gonna restore it. So those are the original values. I guess I'll leave those there. Put this back at the end. But I want to save it again. I think it's getting blown away. Okay, so R11. R11 has a pointer. Call SNPrintf. Go through this. Let's rerun it. Okay. I don't want to go into that. So if I do next instruction, I should be able to not have to do it. Why am I coding assembly? Don't know. Something I can do. Why not? It's fun. Oh, Plus, you know, y'all can watch and maybe you'll learn something. And this is why we have C, because assemblies can be a pain. Okay, so we push R11, so NI is for next instruction, so it won't go into the call. Which I don't want to go into there. Sig. Why is it seg faulting? Oh. Duh, I gotta. Might as well push RSI. Gotta do 2 of them always. Oh. Well, now at least it doesn't sig fault. Which I guess is good. As opposed to crashing. All right, so RAX is how many bytes? Yeah, that seems right. So if we hop over, this is going to take a bit of debugging. It was working before, so clearly either I edited. I feel like I misedited something. So I think my LEA should be right. That should be RDX. Examine hex $RDX. And RSI. Unless I need to grab those values to make them be pointers. So maybe this is a relative address. No, that should be right. So if I break in binary, well, it's not crashing. It's not trying to write to memory, it can't. The index is an RDX, the offset. RSI is the buffer, copy it into R11. Save it, because SNPrintf is gonna clobber it. Oh, it might also clobber. Did I save those? I saved them. DI, SI, DX, CX. Should smash RAX, which is fine. RDX, RSI, RDI. moved RSI into R11. So R11 should be my pointer. Oh, people spam. Thanks. Appreciate that. That gets the value of the buffer, puts it into R13. Should be able to say add. Okay, so copy the buffer into R12, add the offset, which is in R13, move AL into R12. So when we get to write string, it should have the thing, and I think it does. RSI. R11. Okay. So where are we writing? We're writing to R12. So we're looking at write string. So what's at R12? It's also a 1. What's in AL? AL should be a space. AL 0x5e. So we wrote to R12, but it should have a hat in it, not a 1. If it has a 1 in it, then that's wrong. So let's break on test size. Okay. So where is buffer at? It doesn't have it. I don't have it yet. Okay. So R13 has 3. We need to write a character. Go ahead and move into AL 5E. Get the offset in R13. Offset should be, is currently 0. Yep, this is the first thing we're going to write. Okay, so R12 is our offset. R13. Okay, R13 is our offset. R11 is our buffer. So if we step Okay, so R11 is the buffer. Okay. Move RDX into R12. Okay, so we're copying the buffer. No, the top pointer. Offset. Copying the offset into R12. Oh, we're copying the offset. That's an address. RDX is an address, right? RDX is an address. R13 has the value of it, which did I increment? I haven't incremented yet. Okay. So R13 has 1. We're going to save that into the location of R12, which is R. Well, why does R12? The buffer's in R12. We add, we save RDX. Wonder if I needed to save that. RDX is pointing to the same spot. No, it's not the same. RDX and RSI are pointing to the same spot. So I'm overwriting it. Oh, that's not good. That's not what we wanted. I think I need to save it. Actually, so if I just push RSI and then pop RSI, I can do this to R11. RDX. Need to save that. There we go. There, I got that working. That's what we were doing before. Until I messed it up. So save in registers. And when you're in 64-bit, you need to save them in parallel. All right, so we did get our justify print to work. We can then pass it in a buffer address. I think that's what we're going to get to today. So hopefully you guys like it. I think that'll be it for our stream. I'll get some lunch. But next time we'll see if we can get our second line to work. I think we can. I think all I got to do is do some XORing and then put this bad boy in a loop to do both lines at the same time. So, all right. Thanks for watching, guys. We'll talk to you later.